Part 2, state if the given binomial is a factor of the given polynomial. Use synthetic division, see if you get a 0. So when doing synthetic division, I write down all of my coefficients and only my coefficients in a line. And then outside of my synthetic division, I write the number that makes this 0. We want to always divide by the root, not the factor. So -7. All right, let's try the synthetic division. I drop down the 1. 1 times -7 is a -7. I add the column. 3. 3 times -7, -21. Add the column. -2. -2 times 7 is a 14. Add it up, we get a +7. So this is a no. All we wanted was a yes/no answer. It is not a factor. Try the next one. 8, 69, -22, 47, 27, 81. Test it with the -9. Drop down the 8, -72, add the column, -3, +27, +5, -45, +2, -18, +9, -81, 0. Yes, we did just find a factor. This is a factor, this is a root. All right, estimate the value of the 0 to the nearest tenth. On the test, the table will be given to you, but let's practice getting that table. It's a good calculator skill. So first off, we need an estimate. I'm going to say that that looks like it's about -1.4, I would say. Well, let's see if we can get maybe a little more precise. Maybe it's -1.5, maybe it's -1.3. So open up the calculator. I want to plug in x cubed plus 2 into my first y equals. X cubed plus 2. All right, make sure the graph matches. Actually, let me try a zoom 6. That looks about right. Again, still looks like maybe that one's more like -1.3. Let's take a look at the table. So I'm going to go second table set. I'm going to start at -2, so I'm definitely to the left of my 0, and I'm going to go up by 0.1s, which is the degree of precision that we want. Go second graph, and I'm looking for when I switch from being positive to negative, or the other way around, negative to positive. So as long as the sign's flipping, I'm found a 0. And it flips right here between -1.3 and -1.2. And then I pick the one that's closer to 0, so -1.3. I guessed -1.4. Real answer, -1.3. So pretty close. All right, I'll skip the next one, but just as a reminder, look for where the sign flips in the y column, and then pick the one that's across from the number closer to 0. And that is our intermediate value theorem. All right, when adding two complex numbers, you want to add the real parts and the imaginary parts separately, and always bring the real part to the front. So there's nothing to distribute here, so I can rewrite this without the parentheses. To start, draw two arrows of the 3 and the 4 coming together to become a 7, and the 2i and the 5i coming together to become a 7i. As easy as that. When I'm subtracting, like let's do 23, don't drop the parentheses until after you've distributed that negative. So now I get -7 minus 5i plus 3 minus 3i. Bring the real parts to the front, -4, imaginary parts to the end, minus 8i. All right, when I multiply, we're still going to FOIL, but every time we get an I squared, we're going to replace it with a -1. All right, so I multiply, I'll write FOIL, show my arrows first, outside, inside, last. 3 times -5 is a -15. 3 times 5i is a plus 15i. 5i times -5 is a -25i. Plus 5i times 5i becomes a 25i squared. There's two i's there. But right here, 25i squared, well, I squared is equal to -1. This becomes a -25. Now I combine like terms. That'll combine with the -15 to go to the front, become a -40. And then these are like terms as well, and that becomes a -10i. All right, so -40 minus 10i. Let's look at 25. So first gets me a 48. Outside gives me a plus 32i. Inside gives me a plus 24i. And last gets me a plus 16i squared. But that there becomes a minus 16. Combine like terms, we get a 32 plus 56i. All right, and then let's look at one like 28. So this isn't just a FOIL problem, it's just sort of more generalized distribution. I'm going to start by just multiplying these two. So 7i times -6i becomes a -42i squared, becomes a positive 42. Now that's still multiplying our -3 minus 5i. It's going to get distributed. 3 times 42, 126. So it's a -126. 5 times 42, -210i. All right. Maybe just one more. 31 looks maybe kind of tricky. I'll start by distributing the 7i. Although I think it's about the same either way. You get 21i minus 49i squared. That's going to become a plus 49. So I've got 21i plus 49 times 8 plus 4i. All right, we'll be a little bit more careful with this distribution because I've got the I term in front here. Not a big deal. I think we can deal with that. So I'm going to do first, outside, inside, last. 8 times 21, 168i. 21 times 4 is going to be plus 84i squared. Inside 8 times 49 is 392. And last 49 times 4, 196i. This here is going to become a -48. I'm going to bring the real parts to the front. So -84 plus 392 is a 308. And then the 168 plus 196 is a 364i. All right, call that good for part 2. Good luck studying. Have a good rest of your day.